we've been introduced to the concept of total differentials, so let's compute some examples for actual functions we have in front of us. So we want to find the total differential of z as a function of x and y. So remember that the total differential of z is the partial with respect to x. Actually, it's dx plus the partial with respect to y dy. So to fill this out, we need to find these individual partial derivatives. So the partial with respect to x here, let's say dz, the partial with respect to x, well, y is treated as a constant since we're taking a partial with respect to x. And the derivative of x cubed is 3x squared. So that makes this 15x squared y squared dx plus the derivative with respect to partial derivative with respect to y. X is treated as a constant, 5 is a constant. The derivative of y squared is 2y, so we get 10x cubed y, so 10y dy. And that's how we would get that particular partial derivative, or total derivative. Now we have a w, we have a function of 3 variables. So instead of having 2 components for our total differential, we're going to have 3 components for our total differential. So we're going to have dw equals the partial with respect to x dx plus the partial with respect to y dy plus the partial with respect to z dz. So it works pretty much the way you'd think it would work. So let's find these partials. The partial of this with respect to x, so that's 2x, and these are treated as constants, so we have 2x y z squared dx. And then that has no x's in it, so the partial of that is 0. Now when we take the partial with respect to y, this has a single y in it. These two are treated as constants, so this is x squared z squared. Now we need to take this derivative. Well, this is going to be a chain rule situation. The derivative of sine of something is cosine of that something times the derivative, in this case with respect to y, of that something. Well, the derivative of that inside, z is treated as a constant. Derivative of y is 1. So we have a z. Derivative of yz is just z dy. And then finally, we're taking the partial with respect to z. These two are treated as constant. The derivative of z squared is 2z. So this is 2x squared y z plus, again, this is going to be a chain rule situation. The derivative of sine of something is cosine of that something. Y is treated as a constant. The derivative of z is 1. So that's y cosine yz dz. And that's the idea of computing the total differential.